Hey everyone. Today we're going to continue talking about reactions of acids and bases, and we're going to specifically talk about water. Water is considered an amphoteric substance. Okay, this means that it can act as an acid or a base depending on what it bonds with. Had we spent more time talking about Bronsted-Lowry acids and bases, you would have seen this firsthand, but we ran out of time, so we couldn't. What you really need to know is that when water self-ionizes, it has the same amount of hydroxide ions and hydronium ions. Because it has the same amount of hydroxide and hydronium ions, it is considered neutral because we know that hydroxide ions are part of a base and hydronium ions are part of an acid. We can write a chemical expression for water molecules that self-ionize by having KEQ equal the concentration of hydronium ions times the concentration of hydroxide ions. Now notice we're not putting water in there because you know that water is a liquid and liquids are not involved in an equilibrium expression. This KEQ for water is actually called KW. It is the ion product constant for water. So the KW is what we just wrote down. It's the concentration of the hydronium ion times the concentration of the hydroxide ion. KW for pure water will always equal 1 times 10 to the negative 14th. So in pure water at 25 degrees Celsius, both the hydronium and the hydroxide ions are found at concentrations of 1 times 10 to the negative 7th molarity. Now we can use the fact that pure water is 1 times 10 to the negative 14th to help determine what the concentrations are of hydronium and hydroxide ions for something that is acidic or something that is basic. So suppose we had an acid solution where the hydronium ion concentration was 1 times 10 to the negative second. What would the hydroxide concentration be? I can use KW equaling 1 times 10 to the negative 14th to go ahead and calculate this. You can see I put this in a triangle. Hydronium concentration times the hydroxide concentration is going to equal my 1 times 10 to the negative 14th. However, because this is an A times B equals C type equation, if I want to find the hydronium concentration, it's going to be 1 times 10 to the negative 14th divided by the hydroxide concentration. Or if I want to find the hydroxide concentration, it'll be 1 times 10 to the negative 14th divided by the hydronium concentration. Basic algebra that you guys have all seen before. So let's go back to our problem. Even though this solution is an acid, there is still going to be hydroxide ions, and the base would still have hydronium ions in the solution. So I can go ahead and solve for this by using my KW equals the concentration of hydronium times the concentration of hydroxide equals 1 times 10 to the negative 14th. What this actually equals is 1 times 10 to the negative second times the concentration of the hydroxide ion, because it tells us that the concentration of hydronium was 1 times 10 to the negative second. Now I'm going to go ahead and algebraically divide it over 1.0 times 10 to the negative second, 1.0 times 10 to the negative second. And if I do the math on this, my concentration of my hydroxide ion is going to equal 1 times 10 to the negative 12. Okay? So my hydronium concentration given in the question was 1 times 10 to the negative second, and my hydroxide concentration was 1 times 10 to the negative 12. The big key to these problems is the number 1 times 10 to the negative 7th, which is neutral. If our hydronium concentration is greater than 1 times 10 to the negative 7th, the solution is acidic. If our hydroxide concentration is greater than 1 times 10 to the negative 7th, the solution is basic. there's an inverse relationship between the hydronium and hydroxide, meaning if you have a lot of hydronium, you're not going to have as much hydroxide, or if you have a lot of hydroxide, you're not going to have as much hydronium. The big thing is that you pick one of the ions, either hydronium or hydroxide, and you use it to determine whether a solution is acidic or whether a solution is basic. So what do I mean by that? Let's say that we have the question, what is the concentration of hydroxide ions? If the concentration of hydronium ions is 4.5 times 10 to the negative 7th molarity. Also, is it acidic or basic? I know with the basic equation that Kw equals the hydronium ion times the hydroxide ion. It is giving me the concentration of hydronium. So I know that 1.0 times 10 to the negative 14th equals 4.5 times 10 to the negative 7th times my hydroxide ion concentration. So like I did previously, to find my hydroxide, I took my Kw and I divided it by my hydronium concentration. And I got 2.2 times 10 to the negative 8th. Now, how do I determine whether this is acidic or whether this is basic? You just need to pick one of the ions. It doesn't really matter which one. If I have 4.5 times 10 to the negative 7th, and I'm looking at that, this is greater than 1.0 times 10 to the negative 7th. Okay? That's greater than 1.0 times 10 to the negative 7th. Because that's greater than 1.0 times 10 to the negative 7th, I know that this is acidic. Now, I could have also done that using my base. My base, or my hydroxide concentration, is 2.2 times 10 to the negative 8th. And because I know it's 2.2 times 10 to the negative 8th, this is less than 1 times 10 to the negative 7th. I know because it's less than 1 times 10 to the negative 7th that I have to have more hydronium or less hydroxide, again, making this acidic. Let's real quickly do a problem on the worksheet together, just so you have an idea of what we're going to be doing for 19-1. Oops. We're just going to slide this down. Come up. What is the concentration of hydroxide ions in saturated lime water if the hydronium ion concentration is 3.98 times 10 to the negative 13th molarity? And it's asking if this is acidic, basic, or neutral. Well, right away, I know that my concentration of H3O plus is less than 1.0 times 10 to the negative 7th. And because it's less than 1.0 times 10 to the negative 7th, I automatically know this is basic. I don't have enough hydronium ion concentration. Okay, but now let's figure out what is my hydronium concentration. If I go back to that triangle, Kw equals a concentration of H3O plus times the concentration of OH minus. What I'm trying to find is the concentration of OH minus. So this is going to equal Kw over the concentration of H3O plus. I know that Kw is 1.0 times 10 to the negative 14th. And I know the concentration of hydronium is 3.98 times 10 to the negative 13th. If I go ahead and calculate this in my calculator, I'm going to get 2.51 times 10 to the negative second, or 0.0251. Let's do one more together, just to make sure we're all on the same page here. What is the concentration of hydronium ions in a wheat flour and water solution if the hydroxide equals 1 times 10 to the negative 8th molarity? Is it acidic, basic, or neutral? I know the concentration of OH minus is 1.0 times 10 to the negative 8th. This is less than 1.0 times 10 to the negative 7th. And because I know hydroxide is less than 1.0 times 10 to the negative 7th, I know that hydronium is then going to be greater than 1.0 times 10 to the negative 7th because there's an inverse relationship. So I already know that this is acidic. Okay? The next thing I want to do is I want to look at what I'm trying to find. It wants to know what the hydronium concentration is. Well, going back to that triangle, the hydronium concentration is going to equal Kw over my hydroxide concentration. I know that Kw is 1.0 times 10 to the negative 14th, and I know that my hydroxide is 1.0 times 10 to the negative 8th, and this is going to give me a hydronium concentration of 1.0 times 10 to the negative 6th. And 1.0 times 10 to the negative 6th is greater than 1.0 times 10 to the negative 7th. So it's also telling you that it's acidic. So again, it doesn't really matter which ion you're choosing. You just have to understand on whether it's greater or less than 1.0 times 10 to the negative 7. If you understand there's an inverse relationship between the hydronium and the hydroxide ions, it's actually pretty simple. Okay? That's it for today, and we'll be starting another round of notes tomorrow. So if you have any questions, please let me know. Thanks. Have a great day.